Welcome back to All This Math. This is Professor Parker. Make sure you're subscribed to the All This Math YouTube channel. Make sure you like, share, comment, all of that. All right. Today's video is brought to you by the late ancestor Rosa Parks. Rosa Parks, of course, probably most famously known for the Montgomery bus boycott, kicking off the Montgomery bus boycott in Montgomery, Alabama back in 1955. A lot of other people involved in that. One noteworthy person was Dr. Martin Luther King Jr. when he was real young. You know what I'm saying? Also, she was involved in and supporter of the Republic for New Africa. Please research the Republic of New Africa if you have never heard of that. Republic of New Africa, Robert F. Williams, Imari Obadeli, Queen Mother Moore, um, a lot of other folks. Some of their names escape me right now, but definitely go do your research. All right, now, what are we talking about in terms of mathematics today? We're talking about subtracting integers. All right, subtracting integers. Now, what's an integer? First and foremost, an integer is a number that doesn't have a decimal or a fraction component to it. All right, so 3.4, because of that 0.4 part, is not an integer. 2.6, not an integer. All right, 1/2 is a fraction, not an integer. Now, some integers can be represented as fractions, like 8. 8 is an integer, right? I could represent 8 as a fraction, 8 over 1. But because when I simplify it, it's no longer going to be a fraction, that means 8 is still an integer, all right? So fractions and decimals. If you see fractions and decimals on the paper or on the screen or in the book, know that that number is not an integer once you simplify it. 3.2, that's 3.2. That's 3 and 2/10 or 3 and 1/5 or 3.2. It's not an integer because it's got that fraction. If you convert it to a mixed number part, it's got that fraction part, it's got that decimal part. All right. So if you see fractions or decimals, it's not an integer. All right. So all of these numbers are integers. 19 is an integer, negative 16. Oh, and integers can be positive or negative. It can be positive or negative. Positive 19, negative 16, positive 11. This is technically a positive 17, even though you're subtracting it. Negative 13, technically a positive 11, even though you subtracted it. Negative 18, negative 11. All right. These are all integers. All right. Now, the reason I wanted to do this video is because I wanted to show y'all how these are basically the only 4 scenarios you're ever going to see when you're subtracting. All right. So if you know how to do these 4 types of problems, whenever it's time for you to subtract anything in an algebra class or pre-algebra class, you should be straight. All right. Shouldn't be no issues. All right. So because you're either going to have a positive minus a negative, or a positive minus a positive, or a negative minus a positive, or a negative minus a negative. Those are the only 4 choices. I'm pretty sure. Yeah, there's only 4 choices. All right. Now, there are different ways to show subtraction, just like there are different ways to show addition. My favorite method is using a number line, something I learned when I was in 6th grade back in the year 1990. 1990, when the number 5 Jordans came out, right? Way back in the day. You know what I'm saying? So this is the number line. All right. So you see how, but look at my scale though. Look at my scale. Look what's different about my number line. My scale, I'm going by fives, right? 0, -5, -10, -15, -20, -25. On the positive side, 0, +5, +10, +15, +20, +25. I left out that 30, but we don't need that anyway because our numbers don't go up that high. But but yeah, so you normally your number line, your scale will be by 1, but it don't got to be by 1. And the reason I didn't do it by ones was because look at my numbers. Look at my numbers. I wouldn't have had enough space to account for all of my answers. All right. Now, basically, it's like this: when you use the number line to do subtraction, just like with addition, you locate the first number. You find where the first number is. Almost like using GPS. You locate where that first number is on the number line, right? The operation symbol. If it's subtraction, you move into the left. Memorize that. If you subtract, you move to the left on the number line. If I'm subtracting, I'm moving left. I'm going left, to the left, to the left, like Beyonce said, right? You go into the left when you subtract. How far do you go, though? That's where the second number comes into play. The second number tells you how far you go. So the first number is your starting point. The operation symbol, if it's plus or minus, tells you the direction you move in. The second number tells you how far. Starting point, direction, distance. Starting point, direction, distance. Starting point, direction, distance. Now I'm breaking this down for you, right? I'm giving you the cheat codes, right? I'm giving you the protocol, giving you the algorithms, right? Trust me, memorize it. All right, now look, before we do number 1, something else I want to tell you about is whenever you see a double negative, This is called a double negative. Whenever you have two minus signs next to each other, notice this. This is not a double negative. This is not a double negative, right? See, these are the little details. That's why you should come to the All This Math YouTube channel, because I zero in on stuff like this. Because I've been teaching long enough to know that this is what confuses students when teachers be saying stuff, right? Because if you tell some students, well, use the term double negative, they know the word double means two, right? So they thinking, oh, two negative signs. Then they're gonna be sitting there thinking number three is a double negative. No, that's not a double negative. It's a double negative when the minus signs are next to each other. Even if there were parentheses around this negative 16, that would still be considered a double negative, right? This is a double negative. Minus, minus, minus sign, negative sign, right? And a minus sign and a negative sign represent the same information, right? The same concept is essentially, right? The opposite of something. So this is a double negative. This is a double negative. Even though there are two negative signs, or one minus sign and one negative sign, this is not considered a double negative. All right. Now, back to number one, double negative. What do we do when we see a double negative? We rewrite the expression and create a plus sign or create an addition problem. So 19 minus negative 16 is going to become 19 plus 16. 19 plus 16. Two minus signs become a plus sign. Two minus signs become a plus sign. That plus sign came from the two minus signs. Now, this ain't too crazy. Like, this is like arithmetic, right? This is elementary school arithmetic. 19 plus 16. If you do that mentally, it's a lot of ways to do that mentally, right? What I would do is I probably add the tens and then add the ones. So 10 plus 10 is going to be 20. This 10 and this 10 is going to be 20. Then the 9 plus 6 is going to be 15. So then I put the 20 with the 15 and I get 35. So the final answer for this is positive 35. Now, I didn't really need to use the number line, right? Because I'm doing straight addition. Once I convert this, because of the double negative, I'm doing straight addition, right? But if I did use the number line, and you don't use the number line until after you simplify the expression, all right? After you simplify the expression, I mean, you could still use it, because what you're doing is you start at 19, which is like around here somewhere, right? And then since I'm subtracting, I'm moving to the left. But what am I subtracting? I'm subtracting a negative 16. That means I got to do the opposite of what I would typically be doing. I would typically be going 16 spaces to the left. But because I got to do the opposite of going 16 spaces to the left, because that's what a negative sign means, do the opposite. What's the opposite of moving to the left? Opposite of moving to the left is moving to the right. That's the opposite of moving to the left. Moving to the right. That's the opposite. So, but if I didn't, but because I simplified it and made it 19 plus 16, right? I just started 19 and I go 16 spaces to the right. Because a plus sign means you move to the right. A minus sign means you move to the left on the number line. See our number line? Matter of fact, let me put the negative sign right here and the plus sign right there, because that indicates that this is the direction for positivity. This is the direction for negativity, right? So plus sign means you move to the right. Negative sign or minus sign, move to the left. 19 plus 16, you end up with 35 out here somewhere off the dry erase board. All right, so that's number one. Now we're going to number two. 11 minus 17. Remember, starting point, direction, distance. Starting point, direction, distance. Where's 11 at? 11 is like right there somewhere, right? 11 is like right there somewhere, right next to 10, right? Now, minus sign, I'm going left. How far? 17 spaces. 17 spaces. So 11 minus 17, that's going to be, so if I go 11 spaces, I'm going to be at 0. Then I got to go another 6 spaces to get to my total 17 spaces. So I end up at negative 6. All right, so 11 minus 17 is negative 6. Now, another trick that I just showed to this young brother I was tutoring the other day is when you have a problem like this, when you're doing a positive minus a positive, you can actually, this is a trick you can use. You can actually flip the numbers around, right? Because you're subtracting a bigger number from a smaller number, right? You can flip it around and do 17 minus 11, which is 6. And then you just throw a negative sign on the answer, right? So flip it around, throw a negative on your answer. If you don't use the number line, right? If you use a number line, you just start at 11. And this is why, like, a number line that had a scale of 1 or went by ones instead of by fives would be more beneficial in this situation. But I knew I was going to talk y'all through it anyway, so you're not missing out on too much. All right. So you start at 11, go 17 spaces to the left, we would end up at -6. So again, starting point, direction, distance. Starting point, direction, distance. Starting point, I can't stress this enough. That's why I keep repeating myself. Starting point, direction, and distance. All right, number 3, -13 minus 11. It's not a double negative, so I only got nothing to simplify. So I start at -13, which is around here somewhere. And then I'm subtracting. So I'm going left. I'm going left. I'm going left, right? And then I'm going this far. I'm going 11 spaces. So I'm going from -13 to -11. That's going to take me right here to -24. -24. Now, another way to think about this is -13 take away 11. -13 means you owe somebody $13. Minus 11, you borrow another $11 from them, right? That's debt. You already had debt of -13 of $13. Now you piling on more debt. So altogether, how much debt do you have? Now you owe $24. And because you owe, that is negative. That's where we get -24 from. So like I said, these are the only 3 possible scenarios or ways in which subtraction problems will be set up. Positive minus a negative. Positive minus a positive. Because technically that is a positive. This is positive 17, right? Negative minus a positive. Negative minus a negative. All right, so negative minus a negative. Let's rewrite that because it's a double negative. Double negative, double negative. Double negative, double negative, right? So now I got -18 minus -11. The double negative part is going to turn into addition, right? Now, but again, just like this is not a double negative, and number 3, this is not a triple negative. This minus sign don't count. When we think about the concept of a double negative, we talking about negative signs or negative and a minus sign that are right next to each other, adjacent, right next to each other. Like somebody in class, they sit next to you in class, y'all adjacent, but y'all are what we call juxtaposed, right? That's another word we throw around in algebra, juxtaposed. All right, so this is going to be rewritten into -18 plus 11. Boom, boom, boom. Where -18 at though? All right, it's like right there. 18 is like -18 is like right there before you get to -20, right? It's to the left of -15, but it's before you get to -20. Now, since we adding, we not moving left. We're moving to the right. Remember, starting point, direction, distance. Starting point, direction, distance. So we're moving to the right, and then we go in this many spaces, 11 spaces. So from -18, we're going 11 spaces. If I went 10 spaces, that'd be -8. That put me at -8. But I'm going one more space, so that's going to be -7. Final answer. All right. So we see how we can illustrate this using a number line. So we went from -18, which is right there, all the way 11. We went 11 spaces to the right. It was like -8. So we went to like right there somewhere. End up at -7. You know. So I just want you to understand, like, this is how you subtract integers. Make sure you know what an integer is. You're going to see that term thrown around a lot. It's on the SAT and all that, right? Know what an integer is. Know how to subtract. Double negatives, minus a positive, another double negative. All right? These are the 4 scenarios you're going to see when it's time to subtract integers. All right? Now, I prefer using a number line. There are other ways to subtract, different little tricks, like if you got a positive minus a positive, where the subtrahend, which is the second number in a subtraction problem, the minuend is less. The minuend is the first number. The minuend is less than the subtrahend, right? Right? Minuend less than the subtrahend. So when that happens, you can actually flip these around. You get the answer, which is going to be just 6, right? But then you got to throw the negative sign on that because it wasn't 17 minus 11. It was the opposite. It was 11 minus 17, right? But you could do that until you get comfortable with it. Right, but whatever works, as long as it's mathematically verifiable and it follows mathematical rules. Okay. All right. So just a little bit about that. Subtracting integers. Do your research on Rosa Parks. Rosa Parks is one of them people that like everybody heard of, but a lot of us don't know nothing about her for real, right? Because she just was real popular during Black History Month. I highly suggest we read books, biographies about Rosa Parks, learn more than what what little lightweight, superficial information we might have been given about her, as we were growing up. Like, go read some books about her. You know what I'm saying? Definitely check out the Republic of New Africa and the other people that were involved in that. It's very fascinating. You know what I'm saying? Very fascinating. All right, you go do that and practice subtracting integers. I'll see y'all later.